the basic concrete mix, or we can start with the basic concrete mix. We know the concrete is a homogeneous mixture of cement, fine aggregate, coarse aggregate and water. So basic these things we know. So I can tell you entire volume of concrete, please take care of this slide very carefully. Entire volume of concrete is equal to volume of solids plus volume of voids. Volume of solid plus volume of voids. Or I can write ulta also. I can write like this also. Chalo, volume of void plus volume of solid. Now which solid they are? So I can say volume of concrete will be equal to volume of void means volume of water, volume of void means volume of air. These two things will be there in the voids. Now we will check about the solid. There are a lot of type of solids available here. What kind of solids are available here? Very first solid is cement solid, then fine aggregate solid, then coarse aggregate solid. So this is the very first formula, or I can say the very first formation of one formula. Volume of concrete is equal to volume of water, volume of air, volume of cement solid. Cement solid के बाद आपका आ गया fine aggregate solid, coarse aggregate solid. Okay, now let us convert the things. We know, very basic thing I am telling you. We know mass is equal to, density is equal to, we know the density is equal to mass divided by volume. It means volume is equal to mass divided by density. And we also know the thing that specific gravity of any of the density divided by any of the water. Density of the water. It means specific gravity multiplied by gamma W is equal to the density which you want. Okay. So let us write this again. Volume of concrete. Please listen carefully each and everything. Volume of concrete is equal to volume of air, volume of water plus volume of cement solid. It means mass of cement solid divided by mass of cement solid divided by what I can write, divided by density of cement solid, and density of cement solid can be written as G of cement solid multiplied by gamma W. So this is G of cement solid multiplied by gamma W. Similarly, what is the volume of fine aggregate? Mass of fine aggregate solid divided by G of fine aggregate solid and gamma W. Similarly, what is the volume of coarse aggregate? Mass of coarse aggregate solid divided by G of coarse aggregate solid, gamma W. So this is again one of the formula which we have achieved. Simply I have written what? Solid, or I can say simply I have written mass divided by volume, mass divided by density, mass divided by density, mass divided by density. Now we know this. Right now, if I take cement, it contains mass of cement solid and mass of air. We know mass of air is 0. It means mass of cement solid is equal to mass of cement only. Mass of cement solid is equal to mass of cement only. So mass of cement solid and mass of cement is equal. Correct? But volume of cement solid and volume of cement is not equal. Because in volume of cement, there is volume of cement solid plus there is volume of air. Okay, so it means if I write this and if I want to tell you about the density of cement, then density of cement is mass of cement divided by volume of cement, and this volume of cement and this is the volume of cement solid, both are different. So let us check here. Volume of concrete that can be written as volume of air plus volume of water plus mass of cement solid. We know mass of cement solid is equal to mass of cement only. Then GCS gamma W. Here also mass of fine aggregate only, GFAS gamma W. And this is the mass of coarse aggregate only, GCAS gamma W. But we know mass of cement can be written as gamma C into Vc. Mass of cement can be written as gamma C into Vc. So the next formula will become volume of concrete is equal to volume of air plus volume of water plus mass of cement is equal to rho of cement into Vc divided by GCS gamma W. Similarly, this is also rho of cement, rho of coarse aggregate, fine aggregate, volume of fine aggregate divided by GFAS gamma W. Then similarly, rho of coarse aggregate, V of coarse aggregate divided by GCAS gamma W. Is this clear? It means mass of solid and total mass is equal, but total mass can be written as gamma into V. Total masses can be written as gamma into V. One more thing I can write. You might have studied in soil mechanics that V of solid can be written as V divided by 1 plus E. Total volume of soil divided by 1 plus E. That you might have heard. And total volume can be written as M divided by gamma W, M divided by gamma. It means volume of solid can be written as M divided by gamma into 1 plus E. M divided by gamma into 1 plus E. It means the same thing I can write in this way also. Volume of concrete, volume of air, volume of water. Then again I am writing this, mass of cement divided by rho of cement, 1 plus E of cement. Mass of fine aggregate divided by rho of fine aggregate, 1 plus E of fine aggregate, plus mass of coarse aggregate divided by density of coarse aggregate, 1 plus E of coarse aggregate. So I have written this particular thing in 3 parameters. One is this, second is this, third is this. In three terms we have written like this. So what I have done nothing. Simply let me conclude this, then I will show it again. What I have taken volume of cement solid, that's it. This volume of cement solid can be written as volume of cement divided by 1 plus EC. Very easy. And volume of cement can be written as mass of cement divided by density of cement, 1 plus EC. So this is the third formula which I have written. Similarly, volume of cement solid, now the second form which I am changing the color. Okay. So volume of cement solid can be written as mass of cement solid divided by G of cement solid into gamma W. Because what is the volume of solid or any volume? Mass divided by density. So mass divided by density, and density can be written as G into gamma W. This is the very first formula which I have written. Now I know I can write now the third color. I know the weight of cement, or I can say cement solid ka jo mass hai, the mass of cement solid is equal to the mass of cement divided by GCS gamma W. कोई दिक्कत नहीं. But the mass of cement can be written as gamma into V. So I can say this is gamma C VC divided by GCS gamma W. So this was the second formula which I have written. So the same thing I have written in this manner. Nothing, simply I have changes how I can write volume of cement solid in the different form that I have taken. So what I can do, I can put this also at the back last. And now I can zoom it for you. So this is what we have done. Kindly write all the formulas. Yes, is it clear for everybody or not? Till now, whatever we have written is clear or not? So what I want to prove here is this formula I will use if the proportion of concrete is given in terms of weight. So in terms of weight, I can directly use it. If the formula or if the proportion is given in terms of volume, I will use this particular formula. And if the proportion is given in terms of void ratio, I will give this formula. And there is no formula. We have simply derived all them. In the question, you will come to know how to use these all formulas. And here a lot of concept will also get clear. A concrete mix of 2 meter cube is prepared with proportion of 1:2:4 by volume. Calculate quantity of cement, fine aggregate and coarse aggregate. So now in this question, the proportion is given in terms of volume. It means now the very basic formula will not work. Which formula will now work? Or I can say which concept will work? Volume of concrete is equal to volume of air volume of water. Now volume of cement solid. Volume of cement solid can be written as mass of cement solid divided by G of cement solid into gamma W. That mass of cement solid is equal to mass of cement, and mass of cement can be written as rho of cement into V of cement. So I can say this is rho of cement into V of cement divided by G of cement solid or gamma W plus rho of Fa into V of Fa divided by G of FAS, G of Fa into gamma W plus rho of Ca, V of Ca divided by G of Ca gamma W. Okay, now that's fine. Acha. Now one more thing. One more thing is, let it be. Okay. One more thing is how to write this volume of water. Volume of water can be written as mass of water divided by density of water. And mass of water is how much mass of water? Mass of water is W by C ratio is given as 0.5. It means 0.5 times of mass of cement. And what is the mass of cement? Rho C into Vc. That is the mass of cement. So I can say mass of water is water cement ratio into rho C into Vc. Rho C into Vc. Water cement ratio into this, because this is the mass of water. Mass of water is 0.5 times of mass of cement, and mass of cement is this. Volume of concrete is 2. Volume of concrete is 2. What is the volume of air? 1.5% of the total volume. So 1.5% of the total volume. So 2 into 1.5% of the total volume. Chalo, ye to ho gayi air. Now what is this? This is water cement ratio is 0.5. Rho C is 1470 into Vc divided by this 1000. चलो आ जाओ. Rho C Vc, ये Rho C ये रहा, Vc is Vc, GCS is 3.15 into 1000. चलो ये भी खत्म. आ जाओ आगे. Now 1470 के बाद में what is the density of fine aggregate? अरे density of fine aggregate is 1670. V of fine aggregate. What is the volume of fine aggregate? 2 times of cement. 2 times of cement. So I can write this is 2 times of cement, and this is 2.70 into 1000. चलो बहुत अच्छी बात है. खुशी हुई जान के, मजा ही आ गया. आगे देखो. CA. This is 1580 and this is 4 times of cement. 4 times of cement. GCA 2.65. अरे into 1000 हो गया. Done. You can find the VC from here. You can find the VFA from here. Also you can find the VCA from here. Also you can find the volume of water from here. Each and everything you guys can find, please find it. V of this is coming as around. Are you getting this? Volume of cement approximately इतना ही आएगा. चलो, multiplied by 2, then it will be 0.828 meter cube. Multiplied by it again 2. This will be 1.656 meter cube. What is the volume of water? What is the volume of water? Volume of water is this. Volume of water is 0.51740 divided by 1000 into Vc, 0.414. This entire amount is volume of water. Do not multiply 0.414 directly with 0.5. Why? That is by weight, that is by volume. Here it is weight, here you are calculating with volume. So directly apply here. So 0.51740 into 0.414 divided by 1000. So this comes out to be 0.3043 meter cube. चलो, अब देखो आप दुनिया की सबसे खूबसूरत बात यह है, पूरी दुनिया की सबसे खूबसूरत बात यह है कि आपको बनाना था. You were supposed to prepare the concrete of 2 meter cube. You were supposed to prepare the concrete of 2 meter cube. And what you have done here? You can see this and this. Simply add all of these dry material. Array 414, 828, 1.656. Oh my God. This is 2.898 meter cube. Oh, it means again the same problem. To make a wet mix of 2 meter cube, I need 2.898 meter cube of the dry system. The same thing we have learned in what? The same thing we have learned in mortar. There 1.25 times, here how many times? Divide by 2. At least 1.45 times it came. At least 1.45 times it came. It means in case of concrete, once you add the water, volume will more decrease. Why more decrease? Because you are doing mixing, and mixing will result in a removal of entrapped air. Here the entrapped air is more because 3 ingredient: cement, fine aggregate, coarse aggregate. 3 चीजें. There are 4 things available with you. There was only cement and fine aggregate. Here cement, fine aggregate, coarse aggregate. 3 things. आया मजा? आया मजा? 3 items and 1.45 times. And let us assume I have given you this data 1740, 1670, 1580. I have given you this data. If I even fluctuate the density by 10 amount, na, let us say instead of this, if I give you 1440, I am telling you drastically the answer will change. Drastically this answer will change. If I simply change this 1770 to 1440, drastically this will change. It means that time, let us say the answer is coming 3.02. It means it is more than 1.45. If I change this value little bit change, if I change this value little bit change, it means that's why again I am telling you volume batching is not preferred, because see, in volume batching how much take care you have to take, how much safety you have to measure. If you want to find the weight of this, can you tell me what is the weight of this much? Can you tell me what is the weight of this? Can you tell me what is the weight of this? Can you tell me what is the weight of this? Yes, you can tell. I have given you volume of cement. I have given you density of cement. You can find me mass of cement. Mass of cement will be 1770 into 0.414. This much kg is the mass of cement. Okay. Mass of fine aggregate. Mass of fine aggregate is 1760 into 0.828. ठीक है. Mass of coarse aggregate is 1580 into 1.656. ठीक है. देखते हैं how much is the mass. So 1470 into 414. This comes out to be 608.6 लिख देता हूँ. 8.6 kg. 1760 into 0.828. This comes out to be 1382.8 kg. 1580 into 1.676. This comes out to be 2616.5 kg. Can anybody tell me what is the proportion you are getting here? What is the proportion you are getting here? If I take this as 1, then what will be this? 1382.8 divided by 608.6. This comes out to be 2.72. Then this comes out to be 2616.5 divided by 608.6. This comes out to be 4.3. So this is the weight proportion, and this is what our volume proportion. You can see the difference between weight and volume proportion. You should not think like that, sir, volume proportion is 1 to 4. Then always this will be the weight proportion. No, it will be changed depend on the density. And that's why only the BIS code has, not code, and approximately idea has taken that if you want to make 1 meter cube of wet concrete, approximately 1.5 times of approximately 1.5 times, even more than 1.5 times dry material you have to take. So that note you can write over here. Just below the question. It can be a note. To make 1 meter cube of wet concrete, approximately 1.52 to 1.54. Here it is 1.45. In our case, it became 1.45 times, but it is not always possible. Approximately 1.52 to 1.454 times dry material has to be taken. It is 2.27. This is 2.27. Okay, no issues. 2.27. 2.27. So this is, you can say this is weight proportion, and that given is volume proportion. Both are completely different.